Okay, let's dive into this. Welcome to the Explainer. If you've ever worked on a modern software system, you already know the high-stakes reality we're dealing with today. Modern applications absolutely must handle massive, relentless volumes of tasks, and they have to do it without breaking a single sweat. We've all seen it. When traffic spikes, traditional systems crash, resources bottleneck, and users just walk away. That is, unless those systems are built differently from the ground up. Today, we're going to see exactly how that's done.
Here is our roadmap for where we're headed. 1. The reactive paradigm. 2. Enter the play framework. 3. Mastering asynchronous programming. 4. Reactive streams with Akka. And 5. Scaling your applications.
Section 1. The reactive paradigm. The why of modern apps. Because honestly, we really need to understand the underlying theory before we can start mastering the tools.
So we've got to acknowledge the pain points of traditional application architectures first. Under heavy load, older architectures basically just block operations. They literally sit there waiting for one task to finish before even looking at another. Which brings up a fundamental question. What exactly is reactive Java development, and how does it fix this mess?
Well, the answer really lies in the Reactive Manifesto. This is essentially the industry standard for creating applications that maintain top-tier performance under immense pressure. It defines a paradigm focused on building systems with 4 absolutely core tenets. They must be resilient to failures. They've got to be highly responsive to users. They need to be elastic enough to scale up or down, and they must be entirely message-driven to manage how data flows.
Now, the crucial part is how we actually achieve those tenets in practice, and we do it through a few key features. First up, asynchronous data streams. This means your application handles the propagation of change by dealing with events asynchronously, right as they happen. Second is back pressure. This one's vital. It basically allows your system to control the flow of data, acting like a pressure valve to ensure stability even when the load gets incredibly heavy. And third, an event-driven architecture, meaning the whole application responds dynamically to changes or events within the system.
Section 2. Enter the play framework, the ultimate solution.
If the Reactive Manifesto is our theory, the play framework is the hero built to actually execute it. Let's just walk through its high-level features step by step so we don't get completely overwhelmed before hitting the code. Play is built from the ground up to be entirely stateless and non-blocking. It has built-in asynchronous support right out of the box. For us developers, it offers an unbelievable quality-of-life feature called hot code reloading, meaning you see your changes instantly without ever having to do a server restart. And finally, it's inherently RESTful by design, making it totally ideal for web services and APIs.
To make this crystal clear, think about the contrast between traditional web apps and the Play framework. Traditional apps rely on blocking I/O and state. It's exactly like waiting in a single checkout line at the grocery store. If the person at the front gets delayed with a complicated order, every single person behind them is blocked, just standing there waiting. The Play framework, though, uses non-blocking I/O and is completely stateless. It's more like a highly dynamic system where cashiers can instantly pause a delayed order to help the next customer in line. The processing literally never sits idly waiting.
Section 3. Mastering asynchronous programming. The how. Let's move to the execution phase and see how this builds into actual Java development. Now, what's really interesting here is how beautifully Play integrates with existing Java tools to write this non-blocking code. Think about Java's completable future in action. By utilizing supply async, we can simulate a heavy, long-running operation, say a complex database query or reaching out to a third-party API. In a traditional setup, the server would just freeze, waiting for that database to respond. But because Play supports this asynchronously, the operation is shoved to the background. It doesn't block the main thread. Your server stays wide awake and alert. Once the data is finally ready, then Apply grabs it and moves it forward. It's running concurrently, which vastly improves your system's efficiency without forcing you to write really complex manual thread configurations.
If we map out the lifecycle of handling these asynchronous HTTP requests, it's a simple 3-step process. Step 1. A request is received by the framework. Step 2. Instead of tying up server resources waiting for the database or an API, the processing is handed off in a non-blocking manner. And Step 3. This allows the server to immediately pivot and begin handling parallel requests. The major takeaway? Under the Play framework, the server never waits idly.
Section 4. Reactive streams with Akka. Managing the flow.
Play doesn't do this entirely alone. It actually sits on top of a powerful engine called Akka. And this brilliantly illustrates how they work together to support reactive streams with non-blocking back pressure.
Imagine you're generating a massive amount of data, but then you use a throttle method to strictly control the flow, allowing exactly 10 elements per millisecond. Think about what happens in a normal application during a massive traffic spike. The system gets completely flooded, runs out of memory, and just crashes. By strictly shaping the traffic dynamically, Akka communicates its capacity upstream. It guarantees your application can handle data streams efficiently without ever getting overwhelmed.
Section 5. Scaling your applications. Let's zoom back out to the macro level and talk about the payoff.
When it comes down to it, it's all about the big 3 benefits. First up, scalability. Because Play's architecture is stateless, you can seamlessly scale horizontally simply by adding more instances when user load increases. Second, resilience. Thanks to the reactive model and its tight integration with Akka, your system fails gracefully and actually recovers without crashing the entire application. And third, efficiency. Asynchronous, non-blocking programming guarantees that you're maximizing your hardware's resource usage, which means you stay snappy and responsive no matter the traffic.
So, to bring it all together, let's map the most common developer questions directly to the solutions Play provides. Are you building microservices? Yep, Play is an excellent choice because it's RESTful by design and utilizes Akka for distributed systems. Do you need high scalability? Yes, that stateless architecture allows for incredibly easy horizontal scaling. Are you interested in using other languages? For sure, Play fully supports Scala, which offers fantastic functional programming features that just perfectly complement this reactive nature.
As we wrap up this explainer, I want to leave you with one final provocative thought. Take a really hard look at your own systems right now and ask yourself, is your current architecture genuinely resilient enough to handle tomorrow's traffic? If the answer is no, or even if you're thinking, I'm kind of not sure, it might be time to seriously rethink your approach and look closely at the non-blocking, asynchronous power of the Play framework. Thanks so much for joining us for this explainer. Keep building, and we'll catch you next time.